All right, let's jump into topic two, similar polygons. One thing you're going to notice here, from first semester when we talked about congruent figures and congruent shapes, that meant that they were the exact same size and that they were the exact same shape. What we're going to have going on here with similarity um, is that they're the exact same shape, and you'll notice I've kind of highlighted that part here, same shape, but the size is different. And one of the ways that, a quick little connection there is if you're looking at a photo on your phone or a tablet or something and you want to enlarge it, you expand it out. It's the same photo. It just looks, a larger copy of it, and then you shrink it back down. That's what we're talking about with similarity. It's the exact same thing, just in a different size. So just like first semester with congruence, we always wanted to make sure that we had, we called this um, a congruency statement. But now, if you'll notice, that symbol is slightly different, and you'll notice here where it says the symbol is the similarity symbol. So instead of congruent, we're using similarity. So in order to write this, this is saying start at Q, and then I always just like to use this little arrow. This says QUAD. So that means I need to move in this direction. So that's similar to LITE. Here's L. And if you remember, Q and L go together. U and I go together. A and T, D and E. So as we look at this, I move in this direction. And so then we could identify the different pieces. QU would correspond with LI. Angle Q is congruent to angle L. So up here it says their angles are the same, and having the angles the same means that that's going to keep the shape the exact same. All right. The sides are going to change length, and those have to remain proportional. So that's why we've set those up as a ratio here, because those need to be proportional to each other. All those ratios have to be equal for this to end up being a similar figure. So you notice we listed all the corresponding angles as being congruent because that keeps the same shape. All these ratios of the corresponding sides, so there's QU once again and LI, UA with IT, AD corresponds with TE, and DQ with EL or QD with LE. And remember, you could do that up here. There's QU, the first two letters, and there's LI, the first two letters. UA, second and third. IT, second and third. AD, third and fourth. DE, third and fourth, etc. in terms of kind of how we interpret that similarity. All right, so let's scroll down here and let's look at a kind of an application example. Actually, if I remember correctly, let's jump to this next page. So I think this is how we went through it in the notes in the classroom, was to try to have a good little connection between what that example did and how we could translate it directly here. So scale factor, it's the ratio of any two corresponding lengths in two similar figures. So it says state whether the two polygons are similar or not. And we just said that the angles have to be congruent. All the corresponding angles have to be congruent. And then we also have to have the ratio of the sides all be proportional. All right, so that's what we're going to look at with this example. You'll notice up here with scale factor, in terms of scale factor, depending on which figure you're looking at, um, small to large or large to small doesn't make too much of a difference. So if you're using something as 1/10, that's really the equivalent of 10 over 1. It just depends on the perspective you have for the problem. So if I was doing the problem and I looked at this as the larger or the smaller shape to the larger shape, I might have, my scale factor down here set up as 5 over 16, or that ratio. If you looked at it as 16 goes with 5, then all of these would just be flipped, and that's still perfectly fine. You'll just end up with a slightly different value, uh, but that value, if they are congruent, congruent angles all be the same. If the sides are all proportional, that value should be the same for all of them. We'll kind of talk about that here in a moment. All right, so let's look at this example. And the first thing, a lot of times the easiest thing to recognize is if these angles are all congruent or not. This example is easier because there's one marking on each of those corners, and then you look down here, there's the corresponding one markings, two arcs and two arcs, there's the two and two. So you know if you reflected that, that those angles would match up and they would all be congruent. So that was an easy one to check. Here we had to do a little bit of remembering from first semester with our quadrilaterals, is that if this is a parallelogram, these opposite angles are going to be congruent, and then same side interior angles are going to be supplementary. So this is going to be 100 degrees, and then that means that this has to be 80 because those add to 180, and then opposite angles there would be congruent. So same type of deal holds true here, just a little greater level of difficulty there in terms of determining congruent angles or not. So far on both of these examples, we have the corresponding angles congruent. So the biggest key then, after we've proved that, is to see, are the sides going to be proportional or not? So down here, like I had said before, if I went from, this, if you want to think of it as a smaller shape to the larger shape, and sometimes you'll see in my notes where I'll draw arrows and things like that, and that just means, hey, I'm going from here to here when I set up my ratios. So I used 5, and 5 corresponds with 16. What you have to kind of notice with this one is that there's a little rotation and a reflection that takes place so that we can appropriately get those matched up. So 5 would go with 16, 6 would go with 24, 5 over 16, and 6 over 24. If you kind of went all the way around there, here to here, 6 with 24, 5 with 16, 6 with 24. When we simplify these, here's what we end up with though. It's 0.3125, and then the very next one is 0.25. These are not equal, so immediately at that point in time, I know these are not going to be similar. And then I had talked about, well, what happens if you had done 16 over 5 and 24 over 6? 16 divided by 5 is going to give you 3.2. 24 divided by 6 is going to give you 4. So you'll still be able to determine, even if you had, set these up opposite of me, such as 16 over 5, 24 over 6, 16 over 5, 24 over 6. This would have been the work that you came up with. All right. Looking at this second example here, are the sides proportional? So I'm going to match them up, and it looks like I went from 28, and then 28 went with 35. So I was going from small to large, and a lot of times that's kind of the approach that I take, just so that I stay consistent. Sometimes that consistency from problem to problem, helps us, one, with our confidence, and then two, with our accuracy. So that's kind of my approach that I took there. So 28 goes with the 35, and then 20 over 25, and then 12.4 with 15.5, and 12.4 with 15.5. And when I divide each of these out, I get 0.8, 0.8, 0.8, 0.8. And that's what we're looking for if it's going to be similarity. All of those ratios are equal, so all the sides are proportional to one another. And if you had done, 35 over 28, 25 over 20, 15.5 over 12.4, and same thing there, you would have ended up with 1.25s. That would have been your work, which is perfectly acceptable. And then you could justify and say, yep, they're similar. It also asks up here, what is the scale factor? So this is where we talked about that 1/10 or 10 over 1. You'd be looking at something that was either a 0.8 or a 1.25. These are both perfectly acceptable. It just depends on, were you going small to large or large to small? And it didn't state which one to do, so either one of those would be acceptable there. All right. So that kind of, leads us in a little bit with, trying to find matching pairs of sides, because that's kind of a critical step. If we go back to this example from the previous page, so I'm going to clear this out. And switch back over here to the pen. All right, so here's what we did. It says that they are similar. So if they are similar, that means I know all corresponding angles have to be congruent. So they told me that this angle right here is 45, and if these are similar to each other, and it tells me B is the second letter, that means it has to go with X. This also has to be 45. All right, if this is 90, then Y has to be 90, and it is. And then let's see, this is 120, so that means that D has to be 120. You'll notice this 360 in here that I put. If you remember from first semester, the interior sum of a quadrilateral is 360 degrees. So what we ended up doing was 360 minus 120 minus 90 minus 45, and that left us with 105, which should be the exact same measure as W. So that kind of takes care of Number one, it said, hey, they're similar, so you should be able to fill in missing angles, and that's not too bad of a process. Let me clear that out. So now let's talk about the missing sides. That's really kind of the critical part of this topic. So the key here, and this is what I always tell my students, is look for the pair of sides that correspond, and they give them to you. So in this case, you'll notice I put, circled it and put a big star next to it. That's the pair of sides we know both in both figures, meaning 11, this AB side. If I take a look, here's AB, that corresponds with WX. If I tried to use AD, notice over here, WZ was not given. So that's going to be difficult. This was 4 for CD, but I didn't know this length at all. And this is BC. I don't know that length, but over here I know it's 150. So the only pair of sides that match up is that 11 and the 110. So whether you think of it as going from small to large, like I set it up here, 11 over 110 is then going to be equal to, we just used a variable here. We said, okay, this is going to be called M, and that goes with 150. So this 11 over 110 ratio has to be equal to whatever this value is, M over 150. And then it's just like topic one, I'm going to use my cross products. So 110 times M and 11 times 150. Could you set this up as 110 over 11 and 150 over M and solve it? Yeah, perfectly fine. You're still going to end up with 15. Once I found this value of 15, that's what I wrote down right here because that's the corresponding side that it goes with. And then what we ended up doing, I think probably on the sideboard, was we took, 4. And I think what we talked about was, hey, if you look at 11 and 110, this could become 1 over 10. So if we simplify it, it could make it even easier if I think of this as like 4 and, let me call this x or something right here. Then I could go with 4 over x. Well, that's nice because that is x, and then 4 times 10 is 40. There it is. If I was using this 1 over 10, and remember this 1 over 10 is just this simplified version of this. 11 goes into 11 once, 11 goes into 110 10 times. And so what I'm able to do is take that and set it equal to 8 over, if you want to, call this a lowercase y or something like that, 8 over y. And now if I look, here's y, and then 8 times 10 is 80. That's how we come up with that value. So sometimes by simplifying your scale factor there, that can be kind of a useful piece in the process and kind of help you out. All right, so let's jump down. I think there's maybe an example back here. Let's take a look at this one. So, followed a similar approach, figure out the pair of sides that go together. You could use 3 over 8, or you could use 8 over 3. Doesn't make a difference. A lot of times I go small to large. So that means that 3 goes with 8. And that means if I'm solving for x, that means x goes with 4. All right, so 3 over 8, sorry, here we go. 3 over 8 is equal to x over 4. And then I went ahead and solved. This 2 goes with y. So you'll see 3 over 8 is equal to 2 over y. And then I just went ahead and solved using that skill from topic 1 of being able to solve a proportion. All right, so that's, really the main idea, if you think about this topic in particular, is going to be looking at an example or looking at a problem and, can you decide, hey, x and 4, I don't know both values. 2 and y, I don't know both values. This side isn't labeled and neither is this one. The only pair of sides that I know both is that corresponding pair right there. That's the critical part to be able to come up with this 3 over 8 or 8 over 3. And then you just have to make sure that what you set up here matches. If you went from 3 to 8, you've got to go 2 to y, or x over 4. If you did 8 over 3, then you've got to go with y over 2 and 4 over x. You just want to make sure that you kind of stay consistent with how you are setting that up. And that kind of wraps up our discussion there with topic 2.